Yeah, for example number 2, we're going to use L'Hopital's rule with an improper integral to evaluate the function x e to the x dx going from negative infinity to 0. So we're going to apply part B of definition 1, where the lower limit is negative infinity, and we're going to convert that to a limit as t approaches negative infinity. So we're going to take this integral and then rewrite it in terms of a limit as t approaches negative infinity, now going from t to 0, x e to the x dx. Now what we're going to do is we're going to integrate by parts. We're going to let u equal x and dv equal ex dx. So therefore, du is going to equal dx and v is going to equal e to the x. So we're going to take this integral and we're going to rewrite it by using uv minus the integral v du. So we have x e to the x going from t to 0 minus the integral of e to the x dx going from t to 0. Now when we evaluate, we're going to get negative t e to the t minus 1 plus e to the t. Now, we know that as e to the t approaches 0, as t is approaching negative infinity. And by L'Hopital's rule, we have the following. So we have the limit as t approaches negative infinity, t e to the t, is equal to the limit as t approaches negative infinity of t over e to the negative t, which is equal to the limit as t approaches negative infinity of 1 over negative e to the negative t, which ultimately equals the limit as t approaches negative infinity of negative e to the t, which is equal to 0. Now therefore, we're going to get this integral, which is going to equal the limit as t approaches negative infinity of negative t e to the t minus 1 plus e to the t. So we know this first term is going to give you negative 0 minus 1 plus 0, which equals negative 1.